Hello everyone, and welcome back to Guided Notes Day 3 in our section on probability and statistics. Today we're going to be talking about conditional probability and some examples related to that. So, conditional probability is the probability of an event B, whatever that event is, knowing that event A has already occurred. So, in other words, in the notation for that, probability of B line A, and that's read as the probability of B given A. The formula for this, the probability of B given A, is that I'm looking for the probability of A and B over the probability of A. For example, Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen, given that the card was red? So, the probability that, given that the card was red, there are 26 out of 52 red cards. There are 4 out of 52 cards in the deck that are queens. And then there are 26 out of 52 cards that are red. So I want to know here the probability that he drew a queen given that the card was red. So I need to do the probability of red and a queen given that the card was red. All right, so that comes out to, when you simplify all of this, you multiply this out, 1 out of 13, and that should make sense because there is only one red, that should make sense because I did four queens, the red cards divided by the probability that the card was red. Okay, let's look at here this yoga example in number 3. There are 62 people that take a yoga class and 42 people that take a spinning class at the gym. 15 of those take both. If a person from these groups is selected at random, find the probability that he or she takes yoga class if you know they take a spinning class. Okay, for this I'm going to draw a diagram. I know that a total of 62 people take yoga, and I know that a total of 48 people take a spin class, and that was 62 in a yoga class, and I know that 15 do both. So 48 minus 15, that leaves 33 that take only spinning, and 62 minus, that should be a 15, that leaves 47 people that only take yoga. So now I want to figure out if a person is selected at random, the probability that he or she takes yoga if you know they take spinning. Okay, so 15 people do both, and I know they take spinning out of the total of 48 people spinning, and that is equal to 5 over 16. Okay, now we're going to talk about probability represented in a different way, and that's represented in a table. So this is recorded the data that pertains to 2 different categories. It shows the results of a poll of 50 randomly selected students. So if you add 18, 10, 6, and 16, you get 50, who were asked whether they prefer to watch hockey or football, and find the probability of each. So let's find the probability that this person selected prefers football and is a girl. Excuse me. So that would look like the probability that she prefers the football and a girl would be 6. So I'm looking at the girl football. That would be 6 out of a total of 22 girls. And that is 3 out of 11 when you reduce it. Now, what's the probability that this person prefers to watch hockey and is a boy? Well, that would be boys who prefer hockey, 10, out of the total number who prefer hockey, which is 26. So you see, you have a total of 22 girls, a total of 28 boys, a total of people who prefer hockey is 26, the total people who prefer football is 24. Okay, so the probability of getting a boy who prefers hockey is 10 out of 26 or 5 out of 13. Okay. We can move on to slightly more complicated or more complex tables here. In number 5, you show the result of a poll of 150 randomly selected middle school students who were asked if they take French or Spanish. So again, we could do our totals here if we need to. We may not need to, but to find the total number of French speaking, to find the total number of Spanish speaking, and then the total number of 6th, 7th, and 8th graders. If I want the probability of a 7th grader who takes French, I'm looking at the probability of a 7th grader who takes French. That's 25, so I'm taking that specific, my desired outcome, over all of those who take French, which would be 150. And that reduces to 1 over 6. Now I want the probability of an 8th grader who takes Spanish. So 8th grader Spanish, that would be 33. Out of the total number of people who take Spanish, that's 68. Okay, you can see how this goes. Finding the total in each of these columns and rows can be helpful and is a good first step in being able to solve these. You'll probably, in most of these cases, eventually need those numbers anyways. Okay, moving down now when we talk about frequencies, I'm going to talk about joint relative frequencies and marginal relative frequencies. Let's just start with this example here. So the table below shows the number of first class and coach class passengers on a plane who checked 1 bag, 2 bags, or no bags. Find the joint relative and marginal relative frequencies, and then find each. Okay, so what I'm looking for is 160 here. I'm looking for the total, first of all, which is 160, and then I'm going to make percentages or decimal values here in this second table. So I'm going to find the values in each category divided by the total number of values. So for example, the number of first class people who took 2 bags would be 16 out of 160, which would be equal to 0.1. The first class people who took 1 bag, that would be 12 out of the total number, which would be 160. Who took 0 bags would be 2 out of 160, etc. And you're going to get the following decimals in this chart as you fill this in. And then a total here, 0.1875 as you add the rows and columns. Now for coach, that would be 52 out of 160, which should be just a little bit less than a third. Going down here, the total number of coach who took 1 bag is 60 out of 160. That should be just over 1/3. And then the total number of coach who took 0 bags, that's 18 out of 160. So you're making a fraction here, setting it up as writing it as a decimal, and then adding up all of the rows and the columns. And as you add up these columns and then the final rows, they should add up to a total of 1, because that would be 100%, accounting for 100% of the data that you've collected. Okay, so now in example A, I'm finding the probability that a coach passenger that did not check any bags. Okay, coach passenger that did not check any bags. That looks like on my chart 0.1125, which as a percentage is 11.25% of the people on that flight were passengers that did not check any bags. Okay, next example, final example on this set of notes is, let's go D. I'm looking for the probability of someone who checked 2 bags given that they're in first class. So now I'm looking at the probability of 2 bags given that they're in first class. That is first class and 2 bags, that would be 0.1, but remember that I want to divide that by the probability that of all of the total, by the total number of first class passengers, So I'm going to take 0.1, which is first class passengers with 2 bags, and then divide that by the total number of first class passengers. So given that they're first class, and that is going to give me a decimal of 0.53. 3 repeating, so approximately 53.3 repeating percent. So 53 and a third of the passengers were in first class and checked 2 bags.